For the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on the chemical properties of saturated monocarboxylic acids. In our last lesson, we discussed carboxylic acids. We described the physical properties of saturated monocarboxylic acids, and we discussed why t'ella, or t'edge, turns sour. In today's lesson, we are going to move forward and talk about the chemical properties of saturated monocarboxylic acids. Let us get started. The carboxylic acids show reactions when they interact with the alkyl or aryl group and the carboxyl group. The carboxyl group is made up of a carbonyl and hydroxyl group. When all of these interact with each other, their properties are modified. Let us start by going through an activity together. We fill a 400 milliliter beaker 2/3 full of water. We add 2 spoonfuls of sodium bicarbonate and dissolve it with the water. Then we put a few drops of litmus solution and 4 to 5 naphthalene balls into the beaker. We carefully observe the beaker while adding benzoic acid 1 pinch at a time. In this activity, the benzoic acid reacts with sodium bicarbonate and gives sodium benzoate, as you can see here. Before the benzoic acid is added, the litmus solution is red. As the benzoic acid is added pinch by pinch, the litmus solution slowly becomes blue. This shows us that the product sodium benzoate is formed. This gives a basic solution in aqueous solution. Students, let us look at some of the common reactions of carboxylic acids. In aqueous solutions, when the cleavage of an oxygen-hydrogen bond occurs, it leads to the formation of carboxylate ion and hydronium ion. Carboxylic acids partially ionize, and equilibrium is attained between the ionized and unionized forms. The process looks like this. Since carboxylic acids are weak acids, they slightly dissociate. Let us look at some examples of reactions of carboxylic acids as an acid. Carboxylic acids react with active metals such as sodium, potassium, magnesium, and calcium to form salts and hydrogen gas. We can name the salts of carboxylic acids by first writing the name of the metal, followed by writing the name of the acid, replacing the end IC, acid, by ATE. Let us look at an example. Sodium reacts with ethanoic acid to form sodium ethanoate and hydrogen. Carboxylic acids react with strong bases such as sodium hydroxide or potassium hydroxide to form the corresponding salts and water. Reactions with bases are simple neutralization reactions. Carboxylic acids react with weak bases, such as carbonates or bicarbonates, to form salt, water, and carbon dioxide. Students, we have just gone over a few of the chemical properties of saturated monocarboxylic acids. Let us do an activity to review what we have just learned. Please name the products formed when carboxylic acids react with active metals, strong bases, and weak bases. You may begin now.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello, everyone. When carboxylic acids react with active metals, salts and hydrogen gas are formed. When they react with strong bases, the corresponding salts and water are formed. When they react with weak bases, salt, water, and carbon dioxide are formed. Let us continue with our lesson. Carboxylic acids also react with ammonia to form ammonium salts of carboxylic acids, which you can see here. Students, let us do an activity. Write the chemical equations for the reaction between ethanoic acid and each of these reagents. Then, write the names of the products formed.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Welcome back, students. I am sure you did well with this activity. Let us go over the answers together. This is the chemical equation for the reaction between ethanoic acid and potassium hydroxide. As you can see, the products potassium ethanoate and water are formed. From this, we can tell that potassium hydroxide is a strong base. This is the chemical equation for the reaction between ethanoic acid and sodium carbonate. Sodium ethanoate, water, and carbon dioxide are formed as products. From this, we can tell that sodium carbonate is a weak base. This is the chemical equation for the reaction between ethanoic acid and ammonia. Only ammonium ethanoate is formed as a product in this reaction. One of the important reactions of carboxylic acids involves the replacement of hydroxyl group by an alkoxy group to form esters as products. In this reaction, carboxylic acids are heated with alcohols in the presence of concentrated sulfuric acid. The reaction is called esterification. It is used to add flavor to commercial products such as wine and honey. In today's lesson, we explained the chemical properties of saturated monocarboxylic acids. We learned that carboxylic acids react with active metals to form salts and hydrogen gas. We learned that these acids react with strong bases to form the corresponding salts and water. We also learned that these acids react with weak bases to form salt, water, and carbon dioxide, and with ammonia to form ammonium salts of carboxylic acids. Students, in our next lesson, we will explain the industrial preparation of acetic acid. This is all for our lesson today. Until next time, thank you, teacher. Thank you, students.